There is, I will talk a little bit about this in terms of its formalism. So the PVM, which is fully specified in Appendix A, we will summarize it here because we're going to use it. I'm not going to go into Appendix A. It's this psi. I believe this letter is capital psi. It's a function, and it basically runs the PVM. It takes some code. It takes a program counter, some gas with which to execute, a set of register values, there's 13 registers, and a memory, like RAM. And it results in some particular exit condition, which is that. Program counter, gas remaining, if any, it could be negative. Final state of the registers, and final state of the memory. The exit condition is kind of interesting. It might be a regular halt. It might be a panic, an irregular halt. It might have run out of gas. Or it could be a page fault or a host call, in which case we have an associated register value. Our gas, if it's a negative, if it's this return gas where it could be negative, then it's a signed 64-bit integer. Yeah. If it's just regular gas, something that's going in where it's unsigned, it's always positive, then it's just an unsigned 64-bit integer. And our registers are all 32 bits. So this is a blackboard character, this n. It means the set of naturals, which is the set of integers, 0 or above. We subscript it to denote the maximum plus 1 value. So n 2 to the 32 represents a 32-bit unsigned integer. Memory for our PVM is characterized with this expression. So blackboard M is the type that we use to represent the RAM of the PVM. It's made up of two components. The actual value, bold V, and the access requirements, bold A. So every byte in memory actually has, we model it as having these two different dimensions, right? We have like the actual byte value itself, which is this blackboard Y, which just means byte array. In the paper, they're called octets because theoretically a byte could be something other than 8 bits. More of a historical weirdness than anything else. But anyway, for to be correct, we say octet. I'm not going to say that now because it's 2 syllables and I'm going to speak enough. I will just say byte. So this is a byte array, 2 to the 32 in size. And that's the value of memory. But then we also have the access characteristics of those bytes. Every byte may be writable, readable, or inaccessible, unmapped. All right. We get a page fault if we try to write to a byte that is not writable, or if we try to read from a byte that is neither writable nor readable, that is unmapped. Yeah. To make things a little bit simpler, or at least easier when specifying what we do in terms of the PVM, we actually have two kind of convenience sets, which are given some memory, given some RAM mu, which exists, is a member of the set blackboard M. Given mu, we have two derivative sets, which are all indices which we can read from and all indices which we can write to. And whenever we need to write some data into memory, we have a set of indices that we are writing to. We basically just make sure that that is a subset of if we're reading from, then it needs to be a subset of this. And if we're writing to, it needs to be a subset of this. And if it's not a subset, then we know that at least one of those indices is invalid to read from or write to. Yeah? And it's just a really easy way of specifying all of these indices must be readable or all of these indices must be writable. If they're not, then there's some sort of, there's a page fault. This isn't so relevant at the moment, but it will be relevant if you move to the appendices and you look at the host calls of the PVM. They make substantial use of this formalism. As I mentioned before, program might terminate regularly, gets a square. It's like, hey, I want to finish, I'm done. Okay, there's a square. It might panic, lightning bolt. It might run out of gas, infinity. It might have a page fault, in which case there is a register associated. That is the address at fault. Right? It means that it tried to read from a place that wasn't mapped, or it tried to write to a place which wasn't writable. Or it might be attempting a host call. This is basically kind of a breakout call that does something special, altering some part of state that is not contained within the machine. Yeah, that is not contained within the PVM instance. It could theoretically alter some state of the machine as well, but I think all of the host calls that we have at the moment don't. They all do something with external state. Good. And that's all we're going to cover. What's going on? That's all we're going to cover for now on the PVM. That's all you should need to know for the usage that we're going to have.